So, generative AI, obviously massive topic, hugely powerful. I'm sure everybody here has already been using it. But the question is, how do we make it work in telecom? And telecom is a bit more difficult and a bit more challenging than many other industries. And some of the techniques people are talking about to make generative AI work in telecom, in an enterprise, as in tuning the data for that private enterprise, just won't work in telecom. So what I want to do in this session is talk a bit about what those challenges are, and how a different type of approach is needed to get to basically integrate Gen AI into telco. And specifically then we'll talk about some use cases, particularly on the MEF-LSO side, and how we can, what kind of things we can do to augment the automation processes today and augment the current AI type of implementations today, because Gen AI certainly isn't replacing any of those. So what I want to do to get started is a really simple example. Nothing to do, it's on the consumer side, so everybody in the room will understand this because we're all consumers of telecom. So if it can just move forward, yay. Okay, let's go back. So what we're used to in telecom, many of service providers here have chatbots already that are delivering, trying to take on some of the simple requests that we get from customers. But obviously it's very limited in what it can do, completely based on scripting, and in a lot of cases hugely frustrating. With an LLM-based assistant, I don't know if some of you at the back can see some of this, but basically, a request comes in, why is my bill so high? Automatically it knows who you are, when your last bill was, what the difference was compared to a normal billing cycle. It gives you 2 reasons why that bill was different. You were roaming, you had some Netflix subscription that was not free anymore. So it gives you everything in one, one sort of simple response, and it does it in seconds. But as we know, Gen AI by itself cannot do this. How do you get that telecom data? It's hugely sensitive. How does it know what kind of information to give? How does it know the telecom business? So that's what we want to talk a little bit about. But first of all, let's be clear. Gen AI has applicability across the entire industry of telecom. Customer care is obviously a big use case because every operator wants to reduce those call center costs, wants to reduce the customer service costs. So a lot are saying, we want to reduce the sort of direct support by at least 50%. But in terms of other areas of the business, you've got sales who can, use Gen AI to understand the customer better, understand the customer, the sentiment of the customer, be able to access information much faster than they could before, be able to personalize things that they couldn't personalize before. But then you've got internally within the business operations, nothing to do with the customer anymore. This is your internal telecom business. How can the marketing team do promotions and campaigns faster? How can you configure catalogs? Catalogs are hard to configure. How can we help Gen AI to be able to configure catalogs without having any expertise at all? And then on the operational side, where that's what I'll focus my use cases on today, how can you help, by having an assistant to a technician in the field who can get access to information immediately? How can you use it to plug the automation gaps that we have? We're making lots of progress with automation, but we still have many gaps in there. So this is the potential, but let's talk about the problems. So one thing's for sure, generative AI needs data from BSS, OSS systems to be effective, to have any real value in the telco business. It has to know data from these systems. If you're a digital assistant, you need to know billing history, usage history, what's the current offer, any top-ups that customer has asked for recently. If you're on the business side, you might need the rules for the catalog. How does the catalog work? What's the hierarchy? You can't even ask an assistant, a Gen AI assistant, to help with that if it doesn't understand how your catalogs are configured in the first place. And on the operations side, it needs access to the inventory. It needs assurance information. So all of this needs to be available. But here's the problem. That integration is not that easy to do, because first of all, if we think of the public market today, if we think of GPT, If we think of Google Bard that's powered by PaLM 2, these are absolutely fantastic models. These models are great because they've been trained on masses of parameters, and not just the internet data, they're trained on dialogues, how to communicate. So it's that capability that's kind of opened our eyes to the power of generative AI, even though they do a lot more than obviously the human communication. But the data, the telecom data is fundamentally super secure. It's highly sensitive. You cannot let those models in any shape or form have access to that data. So that's just an obvious one. But the second one, you'll find many companies say, well, we can fine tune the private telecom data. And basically fine-tuning just means that the public model is trained and is great at what it does, but we can fine-tune just the piece that's relevant for your business. And to keep it secure, we can have that fine-tuning data stored on maybe a cloud edge platform from Azure or an Amazon AWS outpost or something like that. So you're keeping the fine-tuning data that you're going to train on the model separate from the public model. But the problem is telecom data changes all the time. Some of it is even in real time. Some of it might not be real time, but it certainly changes every day, every week. You cannot train a model with data that's constantly changing. This makes telecom very, very different to some industries where, you can fine-tune. So fine-tune is a technique, but it's not a solution. So it's not sufficient. And the third one is some telecom companies are saying, well, we'll build our own large language models. But to get them to be as efficient and effective as ChatGPT, you need to spend an awful lot of money. I think South Korea Telecom is a good example. They invested $100 million in Anthropic. Anthropic is a private LLM provider. And they're going to build their own model that's as good as ChatGPT. But those models are not just expensive to train, they're also cost about $700,000 a day to run. So incredibly expensive tool. So a lot of service providers are probably going to need maybe one of the large public models that exist today, but maybe coupled with some smaller private models for more specialized things like code generation or images or something like that. So we need to try and find ways to use those public models because right now the private ones are a little expensive. So this is where we see a different approach is needed for telecom. And this approach is basically where you have a platform that sits in between the Gen AI model and the end user and the private telecom data. So the model now doesn't speak to the user directly and vice versa. The Gen AI model has no direct access to the BSS OSS data of the telecom. And what happens is you basically have a process now where, first of all, before the user prompt gets to the Gen AI model, it retrieves extra information that it needs for that model to respond in the best possible way. So it goes somewhere, it finds the data it needs, in this case, the private telecom data. It enriches the prompt back to the model. So the model then gets the user prompt as well as some extra information that basically allows it to do and respond in the best possible way. Now, of course, you've got to take security into that. So you have to make sure that anything that's sent to that model that's related to customer information or anything proprietary is obfuscated. So it's fake data that goes into the model. It has no clue that any data you send it is related to a particular customer. And the same when it comes back. And you have to control the accuracy of the response, but we're already doing that because you'll see in the next example, I'm going to build up a prompt. You're already telling the model that it can only do certain things. You're giving it binding it, if you like, in a certain set of things it's allowed to do. So let's maybe build up that prompt. So this is what we mean by a personalized prompt. This is what we mean when we're not giving the original user request to the Gen AI model, but first, we're enriching it with extra instructions. So for example, you're a CSR assistant, if we keep that example as before, the bill. So it's telling it how to act, because Gen AI model needs a context of how to act. We're saying use data from Anne's last 4 bills. Now, I'm saying Anne specifically here because the original user was Julie. So we're creating another name. We're obfuscating the name of the original customer. So use the 4 bills, only use the context information I'm going to give, that you're being given. You're not allowed to go off onto the internet and just make things up. We're telling you that you can only use the data you're given. So with that, in terms of billing data, product history, it'll be given the information, and it'll be given it in a form that it can understand, because this data that comes from BSS systems is not in a format that any GenAI model can understand. So you're extracting the data, you're giving it to the GenAI model, and then you're letting it do its huge calculation. Okay, I've got these 10, 15 data points. I have to sift through all this information quickly. I have to understand the context. I have to create the great response, and I'm going to do that in a second or two. So that's basically what we mean by enriching it. And we use techniques called prompt engineering and retrieval augmented generation to do that. So it's really helping the model get all the data and context it needs to reply in the best way. And obviously, if you're doing that, you're reducing the interactions, because if you're using a public model, every time you interact, you're being charged for that interaction in terms of tokens or something else. So making sure the response is as quality as possible means you're reducing the cost in terms of how much you need to pay the sort of model providers, if you like. So digging down one level below, and then we'll get to the examples next, and I'll spend the most of the time on the examples. So the actual platform that sits in between is 2 key pieces that are needed to make this happen. You've got what we call the knowledge management piece, and the knowledge management piece is the real clever bit that understands everything about what data is needed to be able to solve a particular request. So once the intent is known, okay, this question is about billing, it is able to understand exactly what data is needed, how do I get it, where do I get it from, and it's able to then provide that information to the gateway that can build a prompt. So the knowledge base, which is based on techniques like knowledge graphs in the OSS side that have all the relationships between all the operational products and network assets that you have, all of this information and what operational steps are needed to get from one sort of part, if you like, to a target state. All this is in the knowledge management. And then the trust gateway is just the operational piece. User request comes in, what's the intent, how do I solve it? Ask the knowledge management, it gives me information, I build the prompt, and it goes out. But what's key here is to work with many different types of models, public models, private models. You want to be able to choose the models that you need effectively to work with. There shouldn't be any limit on that. So it's making sure that the platform, if you like, provides the information to each model in the format it understands. Models are similar in terms of how they receive information, but they're not all the same. You want to be able to access any type of data. Obviously, in Netcracker, we're not just saying, hey, you get the info from our systems. Every service provider has many different BSS OSS systems in the network. They have data lake with many systems and many types of data you want to source from in there. So you should be able to access that data from any source in the network. So let's maybe start now with a couple of examples. So this one is the digital operations technician. And in this case, it's really about filling some automation gaps. Because what generative AI doesn't do is replace any of the automation capabilities that we have and are planning right now. It basically augments them. So in this case, we have a technician that basically wants to know which GigE ports are available in a particular POP. We're calling Charlotte POP. Now, that's not a difficult thing to do, okay? This engineer can usually find it out in a couple of hours, so it's not like something that will take weeks or months. But even still, if you connect that knowledge base with your telco data, we can reduce that significantly. So basically what it means is you call upon this digital assistant, and then it invokes certain skills that it needs because it knows you're a digital assistant. So it knows it needs to be level 3, layer 3 kind of engineering skills, network operations skills. And then it has to crawl through that knowledge graph to understand different data points that it needs to give to the GenAI model. So it needs to go to inventory and find out, okay, what GIGI ports are available in this POP and which systems are they connected to. You need to know which ones maybe have a golden config that are ready to be used, so you need config management for that. You maybe need to go to your planning systems, and you need to find out, have any of them been reserved for, sort of new processes configurations that are needed in the next coming weeks or months. You might need to know what alarms are showing, and are these like clean ports that can be immediately used. So you have all that information, and when you get those data points, they are just data points, and all this information then goes to the GenAI model, and it, in a couple of seconds, will sift through all those data points and figure out immediately to that technician, in a few seconds, here's your answer. So again, very effective. There's so many use cases we can have. So again, it's not taking away from any of the great automation we're talking about. All it's doing is, speeding things up or filling some holes in processes that are very manual today. So the next one I'll talk about, take it a bit more to MEF. We had some good panel discussion just now on building payloads for different LSO APIs. In this one, we're going to build a payload for Cantata. So MEF has done a great job in not just building the envelope APIs, but starting to define those payloads on top for different services, which will increase over time. But we all know as well that that's still not plug and play. There are still specializations needed and skills needed to be able to develop that payload and specialize it for the particular service on the enterprise side and in the service provider side. So this is where we're showing how GenAI can help speed that up a little bit more, and as a result, this can really help the adoption of these LSO APIs and these payloads, because you're developing them in a much faster time frame. So in this request, or in this use case, an enterprise comes in. They just want a simple E-line service, 1 gigabit service. They define the points they want them available at, and they define the reliability. If you didn't know this info, there might be some interaction with the GenAI model to be able to get the right context for you to be able to come out with an answer. If it's too vague, you obviously have to have some to and fro to get the information you want to be able to build that payload. But now you've got the info you need. So again, it comes in to the platform. It says, okay, I know this is about building an E-line service. I need to evoke skills like sort of MEF specialization skills and layer 2 skills. So it understands the skills, and then it crawls through the knowledge graph again to get the information it needs on, what identify the POPs and which endpoints can be used, and which Ethernet ports are available, et cetera, et cetera. So it crawls through the knowledge graph, grabs that data from OSS, and it builds eventually the personalized prompt, which will look something like this. This is an example of the personalized prompt that will start to translate it into the language of the model, tell it to convert SLAs to SLSs. It'll sort of give it information that it needs and the context it needs in that instruction to be able to build that payload, and within a few seconds, there's your Cantata payload. So again, incredibly effective means that not only are you saving a bit of time, maybe not a lot of time, but a bit of time, but you are actually helping less specialized people be able to do these payloads. And that can be a very powerful tool in increasing the adoption of these, especially, as we heard, MEF are defining many more payloads, and you've always got to have attributes and specialization needed, so this can be a great way to do that. So the third example I'll give now is about onboarding. Onboarding is a very complicated process. It's a very manual process. Today, we're going to assume in this example that you as a telco provider want to onboard a new partner. You're a retail service provider of NaaS. You're missing a few locations. You want to go out to another service provider. And you've already identified who that is. They've got the right service endpoints, and they've done all the procurement vetting, so you know who that provider is. You're just ready for the business onboarding. So first of all, it's the same kind of principle. You invoke the business ops assistant, and this is where the skills will be more related to partnerships and commercial aspects and operational models. So you'll basically be sifting through this information so that you can define the commercial models that are needed. You can define the SLA agreements that are needed. You can define what happens when those SLA agreements cannot be met. So all this information is gathered, and then the GenAI tool can create the service agreement that's needed between those two partners. Now, this today can be done templated, but the problem with templates is you can't bring in extra context. So you have to sort of manually add in different aspects to these templates, like legal aspects or other aspects. And in addition, with GenAI doing it, it's not allowing you to add things to the agreement that don't make sense. Well, you can't add this clause because you've already said somewhere else something that contradicts it. So you're ending up with a master service agreement that actually is probably much more accurate than you could deliver otherwise, which kind of helps with the step 2, and we get to the smart contracts. So that's basically the part 1, and then we get to the operational side, or the technical onboarding. And this is where now we want to sort of get configure the APIs. Now we're talking about Sonata and Interlude to the partner service provider. Now, you don't know exactly what the services are yet, so you're not building a payload in this case, but you're getting the endpoints ready. So this is where GenAI tool could be used to create that smart contract. It's just built the service agreement. It understands which parts of that make sense for a smart contract. Like maybe an SLA agreement that you're going to enforce 100% at peak hours, but maybe at non-peak hours, you can let it drop to 97%. You could have a smart contract around that kind of thing. So the GenAI model can create these smart contracts, and then you need to configure your endpoints, and then it can perform the integration test that's needed. So again, it can play a really valuable role in bringing more automation to that onboarding process that today is still very manual, very difficult. We've put 30% here. Obviously, this is our best guesstimate of what it could be, but it depends, obviously on the complexity. It depends how much knowledge you put in those knowledge bases for it to sift through the right information. And then the last example I'll finish on is a multi-service network design. So GenAI is all about not just communicating, but building, building designs as well. So in this case, you've already got maybe some partners onboarded, and now you're basically, enterprise customer is putting a request in for an ELAN service. Sorry, not the enterprise. This is now the service provider is putting in the request for the ELAN service, and this ELAN service is going to have points in different countries. So what you're going to do now, first of all, is figure out, well, which partners can I use? I've already onboarded lots of partners. The GenAI tool can be used to assess and figure out which partners will fit the description of this ELAN service and all the parameters that have been given. So very quickly, you can say, right, I know which partner I can have for that. It builds the prompts, it crawls the knowledge graphs. It's similar to the other use cases. And then you end up with a really great customer-facing design in a fraction of the time that it would take. Because when people work on these designs, it can take months and months. If you change anything, if you change, you might have half the ports you want redundant, and then later on you want them all redundant. You might want to move from a model where you started with 4 nines reliability, then you move to 5 nines reliability, and every time you have to start again that design, and across different departments in your organizations, which can take many, many months to agree. So those changes can be made, but they can be done in a fraction of the time, so that then you can put that into your design tool that can automate bringing out a full service spec that's needed. So these are just a few examples. So basically, what's key to make this work is you have to have access to that telecom domain information, and you have to do it in a very secure way. So this model enrichment process, rather than trying to train and then be out of date immediately, the model enrichment, they'll be able to give the model information and context it needs to do its job well, is the way we think makes the most sense for the telecom industry, given its, its complicated and very complex nature. But you have to take care of the security. The security is going to be paramount to make sure that nothing that is privately identifiable is public models. And you need a choice. You need a choice of models. Models are, popping up all over the place. There'll be some great public models. There'll be private models. There'll be everything in between. And this will, obviously, you can see the investment that's going on in these models right now. This will just increase over time. So having something that allows you to access different models to do different types of tasks is going to be very critical. Okay, so any questions?
Go back there. I'll just run over here. Here we go. Thank you.
Two quick questions. When you say obfuscation, right, you know that the public models are being trained on the queries, and the efficacy of the results in order to improve outcomes, right? So PII is also, per GDPR, also linkable data. So that is going to get really, really critical, because linkability is de facto established through the training of the models. So how do you account for that, one? Two, how do you know that the model is actually executed correctly? Right? So where's your proof of correct execution?
Okay. No, two great questions. So the first, obfuscation, which it's taken me a while to even be able to say that word. But the first one, the key you get there is to, you say, identify what is personal data. And that is the key. So we've got, obviously we've been working on this for many years in terms of anonymizing data, because we have all the billing systems and the large carriers in enclaves and have to identify the information. So we have techniques to do that already. But in addition, we've built in machine learning context ways of also identifying personal data in different ways. So there's a lot of thinking and solutions gone into being able to identify that particular data that then gets obfuscated. So that's the first key thing. And then the second one was about the quality of responses, and there's two pieces to that. First of all, the fact that you're binding the model with the only information it's allowed to work on is obviously stopping things like hallucinations, coming out with just crazy things. But you're right, it doesn't mean it's coming out with the perfect results. So you have, basically for all of these, you basically have a number of ways. First, you have playgrounds where you test all the results out anyway. You can test them out on Google Playground, test them out on different types of playgrounds to, see what results are coming back. Second, you can do control loops. So, is the user actually, did it answer what you asked for? So you do control loops for that as well. So there's various techniques that are used to make sure that the data it's coming out with actually makes sense, because obviously that's critical. So yeah, there's multiple techniques for that.
Hi. So this has been actually pretty interesting. So among all the different processes that you actually had mentioned could be created by generative AI, which of these do you think would actually be adoptable faster by vendors as well as SPs? And which of these actually would take a lot more time and the ROI is actually better? So there are different reasons why certain processes should be adopted as a vendor. I mean, I represent a vendor, so we actually have a certain perspective about things, but the SP and the MSPs might actually have a different perspective on what they might want to do, right? So which among these, as from your guidance and your perspective, would be better?
Yeah, okay, no, that's great. So first of all, I think when we were talking about things like the digital ops technician, the digital ops technician use cases can actually be very much worked in the near term. And the key to any use case is making sure that what that knowledge base information has, whether it's based on a knowledge graph, which is how we do it in Netcracker. Well, we use vector databases as well, but that telco knowledge has to be in there. We've already built those databases and knowledge graphs to a certain degree. Then you have to customize them for a telco environment. So if that data is in there, then you can activate that much faster. But in terms of complexity of use cases, the digital ops technician is not a complex use case. Building a MEF payload, that's not a complex. We haven't built that yet, of course, but that is not a complex use case. When it comes to things like redesigning a service, that's another one we think Gen AI can be very good for. A service already, service running, but you might want to change it. Like maybe you've got a new Cisco router that's come out, an upgrade, and you have to build that into your service spec to make sure it doesn't impact anything else, or some other policy that you've introduced and it has to change the spec. So that we don't see as being more complicated. Doing a service design from scratch, that's a little bit more complicated. That takes maybe a bit of iteration to see whether it's coming out with the right designs. Does it make sense? Let's do the feedback. So that's, I think, a bit more, that might take a little bit longer to make sure it's coming out with accurate results in the list I gave.